9th standard, our next topic is on velocity time graph. So in our previous topic, we were looking on your displacement time graph. So now we will see velocity time graph. So it's basically like plotting the velocity on your y-axis and time on your x-axis. That is how we do this. So this is how it will work, just like your displacement time graph. So what we are going to obtain from using your velocity time graph, if you take your displacement time graph, we are able to say about your velocity, whether it is uniform velocity or it's a non-uniform velocity. That is what we were able to obtain. Similarly, using your velocity time graph, I can speak about my displacement. Okay, using your velocity time graph, I can obtain the displacement. Similarly, I can also obtain my acceleration. I'll tell you how. What is your velocity formula? It is displacement by time. So if I multiply my velocity into time, I can obtain my displacement. Yes or no? You just play with your formula here. Velocity is equal to displacement by time. So bring your time this side. Therefore, velocity into time, it is equal to my displacement. Acceleration, same. Acceleration is equal to velocity, the change in velocity by the time taken in a given interval of time. So by looking at over here, this is a kind of multiplication and this is a kind of division. See, if you want to find a displacement, you have to multiply your velocity into time, whereas if you want to find your acceleration, you have to divide your velocity by time. So generally in a graph, you can obtain this by finding the area of a graph. If at all I want to find the displacement provided with a velocity time graph, take an area. You find the area, you will find the displacement. If I want to find acceleration, then I have to use my slope. Slope was introduced to you in your last video itself. Okay, you all know what is a slope means. So slope is nothing but ratio. So if you want to find an acceleration, here you have to use your slope. Take a slope for the given line. You have to take the slope for the given line, whereas in case of displacement, you have to take the area. So first we will have an example for your displacement. How to find displacement in your velocity time graph. Okay, how to find displacement in a velocity time graph. The graph is given like this with the time over here and velocity over here. Okay, time and velocity over here, it is given. So once you see, you break your graph. If you break it, you can find one is a triangle, other one is a trapezium, and the other one is your trapezium. So I told you, if I want to find the displacement, I have to take the area. Okay, I have to find the area. Why? Because your displacement formula is velocity into time. So given time, how much velocity? If I multiply this quantity, okay, time and velocity, if I multiply this quantity, I'll just end up with my displacement. So I have to find what quantity here? Area. So by looking at this is a triangle, and next one is a trapezium, the other one is a trapezium. So in your graph, this is your positive and this is your negative axis. So anything which is going below your x-axis, that is anything which is going below your origin, it is taken as negative, and which is going above your origin is taken as your positive, which means it is going in a positive direction, and the other one is going in a negative direction, which is away from it. So if it is away, positive, just towards us, it's your negative. So using that, so first we will try to find the area of the triangle ABC. So take down your normal graph values. So if you take your, what is the triangle formula? Half into base into height. So using that, your half, base is 4 and the height will be 5. Okay, the height is 5. Using that, I'll write here. Next one, area of a trapezium. Why I have given minus sign? Because this portion is below your origin. Can you see? It is below your x-axis. This trapezium is below your x-axis. Now formula of your trapezium is half into sum of its parallel sides into the height. Again, height will be 5. In this case, height is 5, and sum of your parallel sides, if you add it, you will get up the end up with value of 20. And similarly for the next trapezium, FGHI, you calculate it, you'll end up with your value. So what you're supposed to do to find the total displacement, I have to add area of the triangle plus area of this trapezium, area of this trapezium. So area of triangle is positive, and the area of the trapezium one will be negative because it is in the lower portion. Next one, area of the trapezium, it is in the positive direction, so I have to add it. So this is the example which is given in your textbook. You can go through it clearly, it is given there. So let's go through it. Always remember, if you want to find a displacement in a velocity time graph, you have to find the area. Okay, the main idea to be emphasized here is to find your area. So displacement can be found by using the area formula. Next one, I'm supposed to find the acceleration, the same graph. Okay, I'm just going to use the same graph over here. I'll be using the same graph, same example. So acceleration, I have to find the acceleration for this slope or this slope, any slope. You can take any slope over here. So first I'll take for this slope. Now listen, A, P. This is my slope. This is my first point and this is my second point. So it is 0, 0 and for B. So for B, x-axis is 3 and your y-axis is 5. Now what is our slope formula? Our slope formula is y2 minus y1 divided by x2 minus x1. Therefore, 5 minus 0 divided by 3 minus 0, that is 5 by 3. So which we will write as v minus u divided by t2 minus t1. That is your acceleration formula, which is nothing but your slope formula. Okay, here we are using in terms of y and x. Here we will be using in terms of velocity and time, which means both are the same. Okay, so now listen, it is a positive acceleration. Can you see it is going away from your origin, which means the car is traveling in a positive acceleration. Next one, I'll try to find for this one, B to D. Okay, I'm going to find for B to D. Now at the point B, locate your x and y. So what is your x and y value over here? It is 5, 3, 5. And for D, so if you look at for your D value, it will become, so it will be in minus 5. So taking that value, substitute over here. So 1 will be minus 5. Okay, so minus 5 divided by 5 minus 3. Apply the same formula, y2 minus y1, x2 minus x1. So what is your y2 here? Minus 5. y1 is 5. But here we have one more minus, by which it is getting minus 5. Next one is 5 minus 3. Therefore, it is minus 10 divided by 2, which is minus 5. So it clearly shows it is getting negative acceleration, that is retardation. See here it is coming down. It's negatively accelerated. Okay, so it is negative acceleration. Here it is positive and here it is negative. Now look at this point. So if you look at this point, write your x 4, minus 5, and for this one 9, minus 5. So it clearly shows this minus 5 is not changing. So if I used to find the value for DE, it will become 0. Your y2 minus y1 will initially become 0. How? Minus 5. Listen, for DE, 4, minus 5, 9, minus 5. y2 minus y1 divided by x2 minus x1. So minus 5 minus minus, it will become plus. So initially this will become 0. So here it is not showing any acceleration. Here it is not showing any acceleration, but it is moving with a constant velocity. Here it is showing acceleration because the velocity is changing. Again it is showing an acceleration, which is negative acceleration, but the velocity is changing. But at this position it is not showing any acceleration because it is moving in a constant velocity. Now look at this portion. So what you can tell, it is in a positive acceleration. Here 0 acceleration, here negative acceleration. Can you understand? So from this portion E to G, it is in positive acceleration, and G to H, it is showing 0 acceleration. X to H to I, it is showing negative because it is reducing. So using your graph, you can find your acceleration by taking slope. Okay, displacement means you have to use your area. You want to find acceleration, you have to take your slope. Next one, the object is going to move in a uniform velocity. Okay, uniform velocity means for 5 hours I'm going to travel in the same speed of 40 km per hour. I'm not going to increase my speed. Therefore, it is called as your uniform velocity. So how do we find the displacement? I told you have to take an area. Now look at this. It is a shape of your rectangle. Therefore, area is equal to length into breadth. So breadth is 5, length is 4. 5 into 4, it is 20 meter. And same, I'm going to find acceleration. So Yes, next graph. Okay, we'll go for if it is moving in a uniform acceleration. This is uniform velocity, it is moving in uniform acceleration. Understand the difference between velocity and acceleration. Uniform velocity means the velocity is not changing. Acceleration means velocity changes in a equal intervals of time, therefore it will give uniform acceleration. For every 1 hour my velocity is increasing by 10. Okay, 10 kilometers per hour. So for every 1 hour if it is increases, you'll get an acceleration. Remember your graph, before graph. So this is your acceleration graph. See, so first hour I'm going to travel is 10 kilometer, and second hour I'm going to travel is 20. So I'm increased my velocity by 10. So at third hour I'm also increasing my velocity by 10, so which is called as your uniform acceleration. So if I want to find the distance traveled in this 4, okay, if I want to find the distance traveled in this 4 hours or 4 seconds, okay, let me take it as 4 hours. I want to travel in 4 hours. So what I told you, if you want to find the distance or displacement, what you have to use? You have to use your area formula. So it is nothing but a triangle. Can you see it's a triangle? So half into base into height. What is half into base is 4, height is 40. Therefore half into base into height, you will get your distance or displacement, which is 80 over here. And be careful whenever you're going to put distance or displacement. Okay, next one is acceleration. How do we find an acceleration? You have to take the slope. So I have to take the slope for this line. Let it be, I'll call it as AB line. I have to take the slope for AB line. At point A it is 0, 0. For point B it is 4, 40. What is slope formula? y2 minus y1 divided by x2 minus x1. So 40 minus 0 by 4 minus 0, it is 10 meter s minus 2. So what acceleration is? It is your positive acceleration. Why? Because it is moving in a uniform acceleration. Next one, uniform retardation. So in your previous we saw it is moving in a uniform acceleration. That is why the line is going from here to here in your previous example. Now you see it is retardation. Therefore it will be starting from a maximum point and it will end up to your origin point. That is around your x-axis point it will end up. So this is your retardation. Now again, if I want to find acceleration, I have to find the slope of this line. So if I want to find the slope of this line, y2 minus y1 divided by x2 minus x1. So this is point A and this is point B. So point using this 0 minus 40 by 4 minus 0. So I'll get minus 10. So it shows it is your retardation. Is it clear to you all? So in that case, if it is going in this, okay, in your velocity time graph, if it is like this, it is your uniform acceleration. Whereas if it going to fall like this position is uniform retardation. The same one we saw here. You remember? The same. Listen. It is going in this manner, I call it as your uniform positive acceleration. It is coming down, we call it as negative acceleration. The same one they are explaining in steps over here. Okay, next one is distance. Distance means I have to find the area of this triangle. So half into base into height. What is the base here? 4. What is the height here? 40. So therefore it is 80 meters. And one more note, in your last displacement diagram also I gave a note. Here also you are going to have a note. So you can never have a line which is parallel to your y-axis. Remember the same kind of example, the same kind of note I gave in case of your displacement time graph. So here also you'll have the same example. That is your same note. You can never have a line which is parallel to your y-axis. Within 1 second you cannot increase your speed 10, 20, 30, 40. You cannot do it within 1 second. All this will take place as your time increases. So this kind of graph is not possible in theory. That is in practical also. Next one is your next condition. Now listen. Initially your velocity. Initially the car is moving with a velocity of 10 meter per second minus 1, and after some time it starts to accelerating. Then you will draw a graph where you can plot your acceleration also. Listen, it's going in a uniform velocity. In that case it is showing an acceleration. Then you can draw a graph like this. Okay, this is given in your book. So if I want to find the displacement, I have to find the area of the trapezium. So I have to find the area of the trapezium which is given. Acceleration means slope of the line AB. Is it clear to you all? So this example is given in your textbook. Just go through ones. Okay, next is a different kind. Now I'm not going to speak about an object which is moving in a floor, but I'm going to speak about an object which I'm going to drop it from a certain height. That is your free fall. Just going to drop it from a certain height. So once when you drop it from a certain height, what will happen? At this point, you know your velocity is 0 because I'm not going to give any velocity. So it will come and fall at the ground. So when it reaches the ground, it will have the maximum velocity. So after this, what will happen? It will jump back to the original position. Think about your ping pong ball. If you drop it, it will fall down and go back to its original position. So this is the graph of a graph of your ping pong ball. Okay, so first I'm dropping. So at 0 second it is having 0 velocity. Then after 5 seconds, okay, after 5 seconds it is reaching the ground with a velocity of 50 meter s minus 1. After this 5th second, it is going to go up. Okay, it is just going to go up. As it is going up, it will reach this point. So why it is taken as negative? Because it is going against your gravity. Here it is positive because it is coming towards your gravity, and this is going against your gravity. Therefore it is minus 50 s minus 1. So initially it is at 0. Your velocity increases. Then again it is dropping down, coming 0. Again the velocity increases, but it is in negative because it is going against your acceleration due to gravity. Then it will come back and join to the point. Okay, so the graph and the diagram will be confusing for you. Here you will see it is going it's coming down, but at this position you will find it is going up. Okay, don't confuse, because it is your positive. Why it is positive? It is with respect to your acceleration due to gravity. If you drop anything, it will always fall down. Why it is falling down? Because of acceleration due to gravity. Therefore we will take it as positive. If I throw something up, it will go against my acceleration due to gravity. That is why I'll take minus. Okay, so now look at this graph. So if I want to find the entire displacement, okay, first I'll go with acceleration. I want to find the acceleration of this portion AB. So AB, I have to find slope. So what is this point? A is 0, 0. B is 5, 50. So use that. So your acceleration, what is your slope formula? y2 minus 0, 0. And this is 5, 50. y2 minus y1 divided by x2 minus x1. 50 minus 0, 5 minus 0. Therefore it is 10. Next time we want to find the retardation. Yes or no? Because here it is going up, which is away. Therefore it is retardation. So upwards I have to use my retardation. C to D. So again same formula, y2 minus y1 divided by x2 minus x1. You will get 10, but it is negative. See, both are having same value. One is positive, that is why it is positive acceleration. Another one is negative, that is why you call it as your retardation. Next one, I'm going to find the distance. See, what I'm mentioning here is distance, and displacement I'm doing later. So distance, what I have to find? Find the area. So area of this triangle plus area of this triangle. So area of this triangle ABE. Okay, so half into base is 5, height is 50. So half into 5 into 50. Next one, area of the triangle ECD. ECD. So what is the base over here? 5 minus 10. See, listen, starting from 5, so 10. So 10 minus 5, the base is 5. And what is the height here? Minus 50. Can you get me? It is minus 50. So if you take your height, it will become 50. Half into 5 into 50. Since I am noting for distance, I am going to exclude all your positive negative value. But once it comes for displacement, I have to include my negative value. So for displacement, same formula, area of triangle ABE minus area of triangle ECD. Why minus? Because it is in your below your x-axis. You remember I told in your starting of your class this session, whenever it is below the x-axis you have to take it as minus. So displacement will become 0, but distance will become 240. That is why I told you, whenever you are going to measure displacement, have an account of your positive and negative, because this is positive and this is your negative axis. You have to have an account of all these. So this is what you learn in your velocity time graph. So finally you can conclude from a velocity time graph is, if the line is parallel to x-axis, it is in uniform velocity. If the line is inclined, okay, it is moving in uniform acceleration. If it is in a curved manner, non-uniform acceleration. Listen, they will give graph like this and they'll ask you to write what type of motion it is. The same kind of examples we saw in your displacement time graph, and you will also have the same. How do you differentiate them? Here it is velocity and time, therefore it is velocity time graph. Instead, if they are going to given distance and time, displacement time, that is displacement time graph. Okay, so it is velocity time graph if it is yes, parallel, uniform velocity, inclined to your axis, uniform acceleration, curved to your axis, it is non-uniform acceleration. And next one, so using your velocity time graph, if I take the slope, I can find acceleration. If the slope is positive, positive acceleration. If the slope is negative, negative acceleration. Again, using your velocity time graph, I can draw my acceleration time graph, yes or no? I know my acceleration at every instant. I can find at every instant. Therefore, I can draw the graph. So, the area of velocity diagram, velocity displacement, I can use. Sorry, if the area of your velocity time graph, I can find displacement. Slope of velocity time graph, I can find acceleration. So all these you have learned using your velocity time graph. So it's quite a lot of theory which is put into you. Take your time, go through this unit. Just ask me whatever doubts you have in this. Okay, take your time, and lot of graphical representation questions will come for your quarterly. Use this properly. Okay, so go back to displacement time graph, throw it once, then come back again, learn your velocity time graph. Still we have acceleration time graph. Again, do it, learn it today itself, and ask me the doubts as soon as possible. Thank you.